Oh, we got a fantastic question for you here today. We're working through the 2017 free response section, and we're looking at question number 3. This is a BC, but also a very good AB question as well. We're now that we're on number 3, we're in the non-calculator section, so to speak. And right out of the gate, you'll notice we've been given a graph of f prime. So this is a very common question where everything we do is based off our interpretation of f prime, and we can make a lot of determinations about the behavior of f, whether he's increasing or decreasing, even whether he's concave up or down, because the graph of f prime also tells me information about f double prime. And then we can get into some fun things about, well, how much did f increase? How much did he decrease? And things like that. Now, right out of the gates, this first question, part A, is really a monster question for part A. And everything we do is going to revolve around the first fundamental theorem. So let's say we've got the integral from A to B of f prime. This integral is guaranteed to be f of B minus f of A. In other words, this integral right here describes exactly how much f has changed during the time period between x equals a and x equals b. And usually between, we would say, either the a or the b is going to be given. In this case, we have -2 that's been given kind of as like a starting point for us. And then whatever value you're looking for, in this case, the first one we got to find is f of -6. F of that -6 is going to be the other bound, all right? And so the first problem here is I'm going to set up an integral from -6 to -2 of f prime and set that equal to f of -2 minus f of -6. Okay, now this integral right here, this definite integral, also could be interpreted as measuring the area underneath the curve. So I'm going to focus on this triangle right here, which has a base of 4 and a height of 2, so the area is +4. This value right here was given to be 7. And then we've got to solve for or find f of -6. So I think f of -6 equals 3. Bada bing. All right, now kind of use the same process, but start fresh here and to find f of 5. And this time, I'm going to use -2 as the lower bound and 5 as the upper bound, just because I want that lower bound to be the smaller of the two numbers. And again, this is going to be f of 5 minus f of -2. Now, when I find the area bounded between f prime and the x-axis from -2 to 5, I've got the semicircle that's below the x-axis. That's going to be -2 pi because it's below. And then I've got this triangle that's above, which is going to have an area of about 3. So we could say 3 minus 2 pi is that integral. F of 5 is what I'm solving for. And I've got my 7. So adding that 7 over is going to tell me that f of 5 is equal to 10 minus 2 pi. So those are my final answers, the 3 and the 10 minus 2 pi. All right. If you go into this exam and you feel really good about that first fundamental theorem and how you're going to set it up, how you're going to finish it, and all those types of things, you are going to be in great shape. Like if that was the only thing you knew, I think I could guarantee that you get a 2 on the exam. All right. Now, is f increasing or no, on what intervals is f increasing? Basically, we'd say anytime f prime is positive, that implies that f is increasing. It's that simple. Real simple. So let's say I erase here a little bit. We'll try to clean up these shaded regions. Okay. All right. So when is f positive or f prime? F prime's positive from -4 to or -6 to -2, and then again from 2 all the way until 5. So those two intervals. And watch how I want to write this. I'm going to get real formal here for a second. And let's see. F prime is positive from -6 to 2, and from, that's -2, and from 2 to 5 implies that f is increasing on the closed intervals. Notice how these are now closed. Closed. And again, this all goes back to our textbook definition of, how that f prime value influences our f behavior. Part C, find the absolute minimum value of f. The process that I'm in love with here when I try to find an absolute minimum or maximum value is something that I call the closed interval test. And what goes into that test is the first thing you got to do is find your critical points. So you're going to set f prime of x equal to 0. And you look at your graph and you'll know that -2 and +2 are your two critical points. So now I'm going to construct a table of values that includes my endpoints as well as those critical values. And basically, I'm going to test the values of all of my endpoints and critical points, and my absolute minimum has to occur at one of those for sure. Okay, from part A, we know that f of -6 is equal to 3. From the given, we know that f of -2 is equal to 7. We also know that f of 5 was equal to 10 minus 2 pi. So the only one we don't already have in our back pocket is f of 2. So I'm going to use a setup, similar to what we did in part A. Said, okay, the integral from -2 to 2 is guaranteed to be f of 2 minus f of -2. And let's see, the area bounded by the curve is going to be -2 pi because of that semicircle that lies below the x-axis. We got 7. Nope. I got ahead of myself. F of 2 is the unknown minus, oh man, my handwriting's a disaster. Add that 7 over. 7 minus 2 pi is going to equal f of 2. Oh my gosh, that was messy. 7 minus 2 pi. So now the question is, again, you're looking for minimum. So which number is the smallest? This is approximately, going to be in the ballpark of a 1, because it's roughly 7 minus 6-ish. So I think this value right here is your lowest number, and we're going to just make sure that our final answer is crystal clear here. The absolute minimum value equals 7 minus 2 pi. All right, let's jump into D and see what we got. Okay, so we want to find f double prime of -5, f double prime of 3. And I'll tell you what, hopefully I'm going to give you something on f double prime of 3 that is going to take you to another level when it comes to proving why something doesn't exist. But anyway, all we're trying to do, let's say to ourselves, f double prime is equivalent to the slope of f prime. So if you look at your picture, we would say the f double prime of -5 is going to be -1/2. And all I'm doing is I'm reading the slope of the f prime graph at the top here. And then f double prime of 3, I'm going to slide up and we'll take a look at this one just so we're 100% clear. All right, let's see. So we said the slope right here at -5 was going to be -1/2. Now the question is, what's your slope right here? Well, you'll notice the curve is not smooth at 3. F prime has this sharp point, which means it's non-differentiable at 3, which tells me f double prime of 3 does not exist. Now, sometimes they're going to ask you to prove that or try to, take that idea a little bit further. And the reason it doesn't exist is because of our one-sided limits. The limit is x approaches 3 from the left of f prime does not equal, of f double prime, does not equal the limit as x approaches 3 from the right of f double prime, because the slope from the left side of 3 is not equal to the slope from the right side of 3. And a lot of times in recent years, you had to use this idea of one-sided limits to try to prove why a curve wasn't differentiable at a sharp point. Hey, thanks for hanging in there. I hope you feel like you could get a 9 out of 9 on that question the next time you see something similar, because I really think you will see something really similar to this question. All right, keep chugging. We'll talk to you later.